right.
Should
Hello,
I turn
everyone.
off the camera?
If you want, it's good. You're probably sharing, so I think
Okay.
we're going to be focusing more on that. So, um, hello, everyone. Welcome to RubyJax for the month of June. Today, Jacob's going to be speaking on Strykelang. So, yeah, take it away, Jacob.
All right. So, can you see my screen? Can you see my screen?
Yes. Yep.
Okay. So yeah, I've been doing a lot of stuff lately. Um, mostly creating things that I don't know, I felt like I didn't exist. Things that I wanted that I just couldn't find elsewhere. And in this era of AI assisted code generation, or whatever you want to call this era, um, you know, it's it's a it's a different world. You can do a lot of things that you learn a lot of things. You can it's kind of amazing, really. It's I call it's like the invention of the internet, in my opinion. But so I've been going around and creating things, my own projects that um the things that I wanted. And one of those things was my own programming language. And the reason I created my own programming language was because I wanted a language that was a interpreted language that it's interpreted language. You don't have to compile it yourself whenever you run it, but it's also incredibly fast. And basically the language that I always wanted, to be able to write scripts and do all these things that other language couldn't do. So like a natively parallel language that had an incredible amount of functionality, and you barely had to import anything ever. So like, in Python, you got to import JSON, import this, import that, all these millions of things. Python is single threaded. You can't do multi-threading. You have to do multiple processes and all these different types of things. So that's basically what I did. Is I created a language where I did everything. I took every concept from every other language that I've ever learned and built built it myself. So if you go on exorcism, like I did had the most published exercises on exorcism, and I would go through all these different languages and I would learn about them. Like one thing I learned about was, Clojure. I was doing a lot of Lisp stuff. Clojure is a Lisp dialect, and Racket, and going through all these things. And I learned about threading macros and other things like that. And, doing Elixir and learning about, the pipe forward and all those different types of syntaxes. And, I did 3,500 published solutions and stuff, and just learning about all these different languages. How do you do it in this language and this and this and this? And that led me to think like, I want a language where I can do like all these millions of things in a language, like just combine everything into whatever language I wanted. So that's what Strykelang is it's a language that's interpreted language, a production grade interpreted language that's based on benchmarks, one of the fastest interpreted languages ever created. And the language is written in Rust. So everything is in Rust. Rust is the compiled language like C, but it's safe. It's safe, memory safe, and a lot of other things. It allows you to do things in C that are very difficult to do, like multi-threading in C is very difficult. And so, yeah, I wrote a whole language in Rust, and it's called Strykelang. The reason I called it Strike or Strykelang is I was just trying to come up with a unique name and going around looking at, there's millions of different languages. And I don't know, that kind of stuck with me because I was going for the cyberpunk type aesthetic and things like that. So, yeah. So, yep. Somebody say something? No. So yeah, Strykelang is a language. This is interpreted language. So I can show you code examples of Strykelang. This is Strykelang here, Strykelang code. I have I'm trying to zoom in, but forgot it's trying to zoom me out. But yeah, it's a language where it looks pretty similar to other languages. You've got functions, you've got variable definitions, declarations, definitions, assignments, for loops, while loops, all the standard things that you see in other languages. There's nothing unusual. It's got package names. It's very similar to Perl in a lot of ways. There's no semicolons needed to end a statement. That's something I added because I didn't see the need. A lot of languages like Python and Ruby, they don't need semicolons. And, it uses curly braces to mark blocks. And, uses the P keyword for print because I said, why print? Just say P. Ruby has P. Come on. var versus val. If it's val, it's a constant. That's from Kotlin. If it's var, it's mutable. Things like that. You've got function declarations with parameters. I took the sigils from Perl. So in Perl 5, if you start a variable with the $sign, it's like a scalar, or it could be a reference. If it starts with the @, it's a array or list. If it starts with a %, it's a hash dictionary. Took that because it enabled me to basically, in scripting languages, you don't really want to have to declare the types necessarily because it's more typing. So then the sigils are intermediate. So you can say, oh, well, it's not a list. It's not a hash. It's a scalar ref. So it kind of makes it a little bit more readable, in my opinion. And then the $signs, they allow you to interpret inside a double-coded string. That's standard. And then I took the dot as the string concatenation operator. That's from Perl as well. And I took the hash dereference from Perl as well. So that's a hash reference, and you're getting the key pause out of it. That's a Perl type syntax. I took the converting a reference to an array from Perl. So yeah, it's basically a mismatch of a bunch of different languages. And, I've written now over 227 lines in my language. And that proves that it can do a lot of things. And I've solved all the Rosetta code solutions in it. And yeah, it's basically production grade at this point. So, questions so far?
I have a question. How did you get the syntax highlighting?
Yeah, so I wrote a JetBrains plugin. I have several JetBrains plugins. So by the way, I'm writing Z shell in Rust. I'm the first person to attempt a full Z shell rewrite in Rust. And I have two plugins, JetBrains plugins that I wrote, Strike plugin and the Z shell RS plugin. So the Strike plugin, it brings in syntax highlighting, a debugger, and code completion. I have full code completion I can run scripts, you know, all that type of stuff. So, you know, I can say P, you know, whatever, dollar, going to, et cetera. So that's from my JetBrains plugin. I also have a tool window where I can search through all my different built-in functions that I have. I have over 10,000 built-in functions. I'm the first person to write a language with over 10,000 bare word functions in it. That's verified. So I have 10,435 built-ins. So that could be everything from P to get authors, all these different things. And I've got tons of scientific stuff and everything you can basically imagine. So this is not a toy project at this point. It's complete production grade interpreted language. I use it every day. Every day I have over 24 packages based on Strykelang. So I use Strike GUI all the time. It's a GUI automation tool where you can move the mouse keyboard, take screenshots, get the clipboard within Strike, so you can import packages in Strike as a full package manager. And I have 24 packages currently, and you can import GUI and then do various operations, move the mouse, click the mouse, type keys, everything that you would do with the, you know, GUI automation. I have Strike Selenium as well, so you can write Strike scripts where it's controlling the browser and things like that. You go to my meta, I have a meta repo where I maintain all my projects, well, the 78 active projects, and I have all the Strike packages listed. I have AWS bindings, Azure, Kubernetes, Docker, MongoDB, MySQL, Strike Office, so you can read and write Excel, PowerPoint, PDFs, images, SVGs, all that type of stuff, so I can write Strike scripts where I'm inputting and outputting, you know, any type of Office document. Strike Postgres bindings, Redis, Apache Spark, various pure Strike utilities, ZMQ clients, GCP bindings. So I have Azure, AWS, GCP, gRPC, DuckDB, blah, blah, blah. So this is not a toy language. It's a full language, a full package manager. I use it every day. It's benchmarked as the second fastest interpreted language ever written. And I have benchmarks on the README, and it destroys Python, Ruby, Perl. The only language faster is LuaJIT, but LuaJIT is single-threaded. And Strykelang is incredibly parallel. I will demonstrate the native parallelism. Benchmarks, where is it? Oh, here. I have benchmarks against all these different languages: Perl, Python, Ruby, Julia, Raku, LuaJIT, Z Shell. You know, Z Shell's way slower. Yeah, so it's a very powerful language. I mean, the real question is, why would you write it in Strike? Why wouldn't you just write it in Rust? Well, because in Rust, you have to recompile everything yourself. Every time you make a change to your program, you get to recompile, which, you know, gets annoying. And so, yeah, that's the whole point of interpreted languages, is that you don't have to compile, you just interpret them. So, you know, Strike is written in Rust. It's a crates package. I've got a bunch of, I write basically everything in Rust these days. Everything serious that I'm going to do. So, for example, I wrote Powerline. Powerline, I don't know if people have heard of that. It's a library for tmux power lines and other, you know, status bar lines. I wrote that in Rust, called Powerline RS. First person port power line to Rust. So anyways, yeah, everything's in Rust these days because, well, Rust is incredibly fast and there's no competition really. It has no garbage collector. Golang has a garbage collector. It's like this, you know, just as fast as C, but you get a package manager and all the other benefits. So yeah, Strykelang is written in Rust. Everything's Rust. The entry point, CLI options, everything's Rust. The lexer, the parser. So, you know, in a language you have a string of characters, tokens, right? Your file gets read into memory, gets parsed, what gets lexed in the tokens. So each token, you know, like, oh, that's an identifier. Oh, that's a string. That's another token. Oh, there's a parenthesis, blah, blah, blah. You create the stream of tokens, then you parse that into abstract syntax tree, which is just basically, think of it as like a JSON object that maps out your code. Like, oh, it's a function declaration. Now I go inside. Oh, it's got this args, blah, blah, blah. And then from there, the abstract syntax tree, you get compiled. You compile your tree down to opcodes, VM virtual machine opcodes. And then your opcodes get executed on your virtual machine. And then if you have a JIT, which I do, then your operations get compiled to native code. So interpreted languages with a JIT can actually run just as fast as native code like Rust code or C code. And I have a very powerful JIT that I created for my Z shell rewrite in Strike and ArcRS. It's called FuseVM. It's getting popular, and it uses fused opcodes to speed things up. It's got I forgot how many opcodes. Oh, okay, 189. But it's a virtual machine which I use for 3 different languages. So Strike source gets compiled to opcodes, FuseVM opcodes, and it has extension opcodes. Then those run on the FuseVM, which then, if it can, compiles down to native code via JIT. There's 3 different stages. One of the first people to have a 3-stage JIT, and each stage looks for opportunities to compile the operations to the machine code. And I'm also one of the first persons to have a JIT cache. So whenever I compile programs to bytecode, I store that in a binary file. And then in addition, whenever I'm compiling operations to JIT, I have a FuseVM cache as well of JIT. It's a JIT cache. So a lot of times if I run a program twice, the second time will be orders of operations faster because I've cached all of the bytecode and then I've cached all of the JIT lowering. So then it's basically like native. So at that point, my program is running basically nanoseconds, basically almost as fast as Rust code, native code. So, and yeah, I have a FuseVM JIT cache. So yeah, so I wanted a language that was, you know, basically the ultimate interpretive language. So I created it, and I'll go through some of the things that I did, some of the different things. So you can see in these code examples, S is a binary strike. That's how I usually invoke it. And it's a one-liner first language. So you can just say S and then a string in its code. So can anybody explain to me what this one-liner does in Strike?
I don't know what phi is. It's like
Filter.
Okay, filter. So you have numbers 1 through 20. You're going to filter out the even numbers.
Yes.
And then you're going to I don't know the map one. Are you gonna multiply?
Yeah. So underscore is yeah, you're gonna multiply each element of the list, yes, by itself. So
By itself. So you're going to square it, and then you're going to sum it and print it.
Correct. Yep. So 1 through 20 inclusive range, filter the evens. For each even, you're going to square it, and then you're going to sum it and print it out. Yeah. So, I'm using the pipe forward from other languages, right? Pipe forward means take the thing before the pipe, stick it as the first argument, the first argument to the next operation, right? And that's how it's just a chain. It's a pipeline, right? And that's all it is. It's syntactic sugar. So, yeah, a lot of people who are familiar with pipe forward, they're going to see that and be like, oh, yeah, pipe forward, duh. Then another thing I did, though, was I said, oh, I'm going to take the threading operator from Racket. And what that does is, guess what? I don't need pipe forward because every operation is just automatically threaded to the next thing. So can anyone explain to me what this does? If you know that threading means basically the same thing as a pipe forward, what would this do? Any ideas?
Oh, I think I'm stumped on the QW.
Yeah, so the QW means it's a quoted word. So basically it means that A, B, and C are just strings. So it's a list of three strings. And that's the entry point to the thread. So you take a list of 3 strings, you put it into the thread. You're going to map each string to an uppercase version of itself. Then you're going to join everything with a comma. You're going to print it out.
No, it's the same thing as the pipe, but it looks like it's space limited, so that everything
correct.
In that order just gets piped, like the result of one gets piped
yes.
together.
Yep.
What is that called again?
Thread macro.
Thread macro? Okay.
Thread first. Yeah, so it's thread first macro. That's from Racket, the Racket language. It's a Lisp dialect. Has the thread macro. But I'm the first person apparently to import thread macros to the non-Lisp language. See, here's the Racket thread macro. Thread first. See that?
Yeah.
Yeah. So I took thread macros from Racket and Clojure. Clojure has them as well. And I put them into my language. And I have thread last macros as well, which are different because it takes the thing and it shoves it as the last argument to each function. But generally,
we're gonna cover this later. But how do you do error handling? Like the first thing where to return.
The first thing that errors. You could if you're trying to do it error handling, you could have a try catch in your. I have try catch in your thread macro. But yeah, like the first thing that errors is gonna abort the whole pipeline unless you catch it. And so basically my language has over 10,000 different functions or standard library like P, filter, FI is filter, just short, map, sum. These are all standard library functions. And I have over 10,000. And then on top of it, I can take all these functions and combine them in different, orders and pipelines. So I can do a lot of stuff with the language. This one, I take 1 through 8 arrange, I pipe it into PMAP. PMAP is exactly what you think. It's a parallel map. So it will process 1 through 8 independently. And it will take 1 through 8 and put them as, it will call this expensive function, just some user-defined function with 1, 1, call expensive 1, expensive 2, expensive 3, right? All in parallel. Then it will take the result of that and then put that in the P. Print. Does that make sense? So yeah, my language, other languages have pipe forward. Who cares? Other languages have thread macros. Who cares? Other languages have parallel map. Who cares? Right? Right. It's true. The whole thing of Strykelang is it has everything. It has everything rolled into one. There's no need to use another language. I already have everything. It's the kitchen sink. I threw everything in there. Like this. Read a JSON file, convert it into YAML, then print it out. Doing something like that in other languages takes a lot more. A lot more characters. You got to import JSON, import YAML, blah, blah, blah. And, Strike, the pipe forwards, they're the same. They're all their syntactic structure. So you could say, print to YAML, read JSON, data.json. That's the same thing, right? And you could put parentheses around this because you're just reading the JSON, then you're taking that. Because reading the JSON, it turns it into a dictionary, right? And then you take that dictionary and you shove it into YAML, and now you have a YAML, right? So I just converted a, JSON file to YAML file.
I did this in Ruby about a month ago, and it's not difficult, but it takes surprisingly longer than you'd think. Yeah,
and the whole thing about Strike is that one-liners. Look, this is easy. This is like I have a whole comparison. Why Strike? Well, look at what I can do in Strike versus what it takes in other languages. What if I, even printing, the SHA 256, of a hash of a file. Here it is in Strike, PS256, then the file name. 13 characters. Perl takes 70. Python 80, like things like this. Read a CSV, convert it to, dictionary, convert it into JSON. That's to JSON, then print it. Things like that. And the whole thing about Strike is I can do tons of parallel operations. I'm going to show you all the parallel operations. And I have parallel threading macros. I invented that. So basically, I have a syntax where I can do a thread and I do it in parallel. So I take chunks of my, thread macro and I run them in parallel. Show you that. I also have streaming thread macros where I, instead of between each stage collecting them, I just send them through the stream, which is pretty cool. So yeah, why Strike? Well, the thing is one-liners. I like doing things in one line because this is a scripting language. This is for glue. I don't want to have to write a huge Rust program just to convert something from JSON to YAML. Like, no. Yes, I could write it in Rust, but that's going to take me a while. And then I got to compile it. And then I got to run it. So, yeah. I mean, that's why I created Strike. I created Strike to be the ultimate scripting language for my own purposes so that I wouldn't have to use Python anymore. I don't need Python. I never need it. I have everything in Strike. I don't need Perl. Don't need Python. I don't need awk. I don't need sed. I don't need Ruby. I don't need any interpreted language at all because Strike does everything. It even does. I think I'm the first person to do in the terminal data histograms, visualization, flame charts natively, like no imports, nothing. It's I can demonstrate that. But yeah, so the Strike language, it's let me go to my engineering report. I have engineering report. I've got the index HTML. I've got a reference to all of my different functions. It's very long. And I have an engineering report. So yeah, what it took to get here, 480,000 lines of Rust. Yeah, that's what it took to get there. And, I have 220,000 lines of Strike. So that if I'm able to do 227,000 lines in a language, that means it's basically mature. And I run those strike lines on every CI push in my pipeline just to make sure I didn't regress whenever I make a change. And the thing about Strike is I can interpret Perl 5 scripts. I have basically, as long as you don't use a lot of the CPAN stuff or whatever, like FFI bindings, I can run Perl 5 scripts natively with Strike, which is pretty cool, because then you can take an old Perl script and run it with Strike, and it's going to be immediately way faster. So Strike is in the position of other languages. It's new, but it's very expansive and powerful and fast, and it's kind of unusual in that regard. Like I said, it has over 10,000 different standard library functions, which is way more than anybody else. And Strike, when you how do you install Strike? Well, it's very easy, because Strike, I have a homebrew formula where all you have to do is brew tap my homebrew tap, and then you just say brew install Strike. That's it. The thing about Strike is it's so expansive, and I have so many dependencies. When you install it from source, it takes a while and it's annoying. So I usually just do the brew stuff. So yeah, that's all it takes to install Strike, is a brew tap and a brew install. If you're on Mac, if you're on Linux, you can still use homebrew, or you can do the cargo install. That works from anywhere. It just takes a while because it's from source. So yeah, questions?
Can you show a little bit more on the error handling? You mentioned a try catch earlier.
Yeah. So Strike has try catch. Let's see, that would be in the reference here. Catch. Try. Yeah, so Strike error handling. Basically, the main thing is the try catch. So you do whatever you're going to do in your try, then you catch the exception. And then there's a finally that executes after the try or after the catch, regardless. So that's mostly how I'm handling errors. Strike is mostly dynamically typed. You can opt into typing, like other scripting languages, but I have a whole class OOP system in Strike, which I don't really use that much, because why am I using Strike? I'm using it for one-liners and like glue scripts. I'm not really writing some whole OOP system, but yeah, I mean, I try catch is you can also use eval. Eval is a way to run an operation, and you can catch a lot of exceptions as well with eval. It's like a Perl exception catching mechanism. But so that's the main error catching system, is try catch.
I assume you can re-raise an error after it's caught.
Yeah.
So if you want to check it, okay, is this a specific error? But if it's not, then just re-raise it again, let it fail.
Yeah. Yeah. So yeah, mostly like in the use die or warn. Those are like the Perl type things. You just say die, and it's basically like a raise exception. So like you can say open this file or die. Open the file or die. So if you can't open the file, you're done. Things like that. Or you could wrap in a try catch, and then you could, die inside your try or whatever, and then you go into the catch. So yeah, it's the position for Strike is it's a glue language, it's interpreted language, it's very fast, it's incredibly expansive, and it's very useful, frankly. That's the main thing. You're not gonna, would you write an app in Strike? I mean, you could, but Would you? No, you really wouldn't, because you'd be writing your app in Rust or JavaScript or whatever. You'd be doing Rust and JavaScript. I got tons of apps. I got huge apps. I got, massive, like I've got massive trader view apps. It's over 1 million lines of code. I've got, I do stock trading and all, tons of stuff, like things like that, apps that I'm making. I have over 1,000 tiles. I've got, CSV uploads, reports, like, all these different things. Would I write this in Strike? No, of course I wouldn't write Strike. I would write it in Rust and JavaScript, of course. Like, that's the obvious answer. So yeah, Strike isn't about that. Strike is about glue scripts, like CI scripts. It's about, oh, I just want to convert something from YAML to JSON or JSON to YAML. Simple.
So like your stock server, like obviously run the front end in JavaScript is web, but the back end would be written in Rust for performance.
Exactly. Yeah. So Tori. So Rust, Tori apps, Rust, Tori. That's what I use mostly. Like I have other apps like my audio app, and I've been writing lately synthesizers like this. Can you see this? You see my screen?
Yeah, I see it.
Yeah, so I've been writing synthesizers and things like that. But it's all in Rust. It's a Rust backend with JavaScript front end. That's what it JavaScript and HTML, web stuff. So everything's web based. You do your HTML, CSS, and JavaScript on the front end, and the back end's Rust. Yeah, that's how I do everything.
So, so this language runs on any environment that can run Rust?
Once you compile it to whatever system you're on, then it's native. You don't need Rust. No. You don't. Once you have it installed, like the binary, you don't need Rust. It's binary. Yeah. So when you install it, so when you do brew tap and then brew install, what happens on the brew install is it checks, okay, what instruction set are you using? Are you using an ARM processor? Or are you using like a x86, right? Like on Macs, those are the two distinctions. Are you on Apple Silicon or are you on the old Intel stuff? So that's in homebrew formulas. They say, okay, you're on Mac OS, are you on ARM, or are you on Intel? You're on ARM, you download this and you install it. Put it in your binary folder. You're on Linux, are you on ARM, are you on Intel? There you go. You don't need Rust. It's already compiled.
Okay, so supported operating systems right now are Mac and Linux.
Yes, and Windows. Yes.
Oh, and Windows. Okay, so like
everything. Yes.
everything. Yeah. Cool.
Yep. Mac, Linux, Windows, x86, ARM, 64. All of those.
Do you have like a roadmap, or is it mostly complete? Do you have?
Yeah,
like
I have a roadmap. Yeah, I have a roadmap, but at this point, I have most of my stuff completed. So yeah, why Strike? There's so many languages out there. Who cares? Who cares? The world is flooded with programming languages. It's like, who cares? Who wants another language? Yeah, well, that's true. The whole point is, can it do something that nobody else can do? Yes. If it can, then it's worthwhile. That's my perspective. So, things like, summing 1 through 100. Okay, great. Taking word frequencies and then data dumping them. Okay, whatever. Taking a file, getting the SHA-56 sum of it, hash. Okay, whatever. reading a CSV file and then converting it to JSON, printing it. Okay, whatever. Like, not impressive. Taking 1 through a million, parallel mapping 1 through a million, and each item multiplying it by 2. Okay, that's kind of more impressive, isn't it? 1 through a million, chunk it in the parallel. If you have 18 cores, you chunk it 18 to 18, do it in parallel, whatever. That's pretty cool. Things like that takes a lot more work in other languages. Go into other languages and do like 1 through a million, do a parallel map. It takes more work. And that's the whole point of strikes. It's like, whoa, I can do all this stuff. And that's pretty crazy. In that few characters, that's insane. So Strike, it has reflection maps. It has hash maps. So I can keep track of all my built-in functions, my keywords, my operators, my aliases, my descriptions, my categories. So I can look up, oh, what are all my parallel operations in Strike? Easy. Oh, I want to loop through all my built-ins and print them out, whatever. Easy. Oh, like the other thing that Strike has is, oh, I want to loop through all my variables. Show me all the variables I've defined. Easy. I got parameters. Hash. It's a key value. Key is the name. The value is the kind. Loop through all my parameters are defined. Are they scalars, arrays, hashes? Are they atomic? Are they thread safe? Whatever. It's a live binding. As soon as you define a variable, it gets stuck in here. It's cool. Yeah.
And then when you're writing Strike, how often are you actually writing versus having the AI write everything?
I have AI write Strike all the time. It loves Strike. I've had AI agents write over 200,000 lines of Strike. They love it.
Did you have to write any kind of like documentation skills that it knows?
Yeah, a style guide.
Okay.
Yeah, a style guide. I have the Strike style guide. Because, in every language, especially very flexible ones, there's a lot of ways of doing things, and there's a lot of ways that I don't like. Like in Strike, yes, you can put semicolons at the end of lines, but don't do it, because the whole point is to not have to do that. So then you got to create a style guide. Strike style guide. Use function. Don't use sub. I have sub there because that's a Perl 5 thing. Yes, you can use P. Yes, you can use print, but don't use P. Hello. Yes, you can nest functions, but don't use pipes. Pipe forward. I don't want to look at nested functions. I want to use pipe forward. Pipeline. Don't put semicolons at the end of lines. You don't need them. It's noise. Don't use other idioms like I don't like. Like if you're going to do a double function, you don't need to actually define the parameter of the function. Just do function double is equal to the implicit parameter times 2. See? It's simpler. So I really should talk about the implicit, this underscore thing. What's the underscore thing? Anybody know? What's this underscore? That's weird. Underscore is what?
The first argument.
Yeah.
We have that in.
Yeah.
We have that in Elixir for matching.
Yeah. A lot of languages have that. I took underscore from Scala. That's the implicit parameter from Scala. Ruby has it. Ruby has underscore 1, underscore 2.
That's true.
Your Swift has $0, $1, right? Elixir, tons of people have this. There's nothing unusual. So that's like in Strike, that's what this underscore is. It's the implicit parameter. So if you do map S, which is a stream map, every item that comes through the map, that gets stored in underscore, right? So like in this case, I take all the lines in my list, I stream map them. Stream map means for every item in my list, I shove it all the way through the pipeline. And each one gets shoved through the pipeline individually. I don't wait. wait around for them all to be finished. I just shove them all the way through. So if you do 1 through 5, you're going to see 1 first, then 2, then 3, then 4, then 5. You're not going to see 1 through like everything done 1 through 5. You're going to see each one done first. It's a stream. It's how Unix pipelines work, right? In a Unix environment, when you cat a file, like cat/etc password, and then you say awk, print the second column, and then you say, okay, pipe in the less. So what that does is you take every line, you take the first line, you read it in, you pipe in the awk, it does whatever, and then it gets piped in the less. So that whole thing runs. Then the second line is running right behind it. You don't wait for all the lines to be read and then you go in the awk. No, you stream. Unix pipelines are streaming, right? I do find slash. Does that wait for every file to be found before it goes in the sed or whatever? No, it's streaming, right? Boom, streaming, right? And the pipe forward, like say I'm in Elixir, the pipe forward, that's not streaming. That's eager. Basically, it collects everything, right? You collect all the files, then you send them in a sed, right? So pipe forward is basically like blocking, and Unix pipelines are streaming. So that's why you need the distinction. A regular map is not streaming. It's basically like greedy. So a regular map is greedy. A map S is streaming. But this is all single threaded. What if you wanted to do parallel? Well, that's PMAP. PMAP is parallel, but it's also like greedy. It doesn't stream. So what if you want to do parallel streaming? Well, that's PMAP S. So then you're doing parallel streaming. Yeah. So everything, you have to have basically 4 variants. You know, is it a regular greedy? Is it a stream? Is it a parallel? Is it a parallel stream? You have those 4 different distinctions for basically everything. Does that make questions? So like grep S, that's a stream grep. So every line that comes through here individually is going to get through the stream. I'm not going to wait for this whole thing to collect. I'm just going to grep through everything that comes through immediately. So like this whole thing is streaming. So if I had 1 billion lines, each line is going to go individually through the stream. I'm not going to wait for 1 billion lines to come through and get stored in memory. No, I take each one and I just shove it all the way through. That's streaming. So basically what that means is you could have 1 trillion items and you could have 1 trillion, infinite number of lines, and this is still going to run because it's just going to do one at a time. It's not going to try to take 1 trillion lines in the memory because that crash your program. So anyways, yeah. So if you're having bots write your code, well, the thing about bots is they just do whatever the hell they want. You have to control them and put them in some type of walled garden. They'll just, they'll say, oh, I should put semicolons everywhere. No, you don't need to. Stop. Stuff like that.
Linter yet?
Yeah, I have a linter. Yeah. Yep. I have a linter. So as soon as you make like a mistake, see, the linter static analyzer goes through it, reads your like program, and so like if I'm writing strike in Vim or whatever, I can write strike in Vim. Yeah, I have the linter, it flags everything. But in this case, I have a whole LSP server. So basically LSP, if you're familiar with that, is the way that languages serve up all their info about themselves. Like the linter is one thing, but all the code completion. So like when you're code completing, like what starts with get, That's all LSP, because the LSP says, okay, you got get to the left of your cursor. Therefore, you could be referring to some some function you define, but you could be all referring to all these library functions. Which one is it? That's the whole LSP server. LSP server does all of that. It lints your program, flags all your errors, does your code completion, your tons of stuff. Your refactoring. So I have full refactoring. So if I want to wrap all this in a function or whatever, blah, 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 rename across files, all your snippets and whatever, stuff like that. Yeah, extract a variable from stuff, whatever. Things like that. Yeah, that's all LSP server. So like basically every language has an LSP server. Every major language has LSP. So that's what you do. You use the LSP server.
So what does your input output look like if I wanted to run, let's say, like a binary that's going to give me like a string result back, like something to standard out back?
Yeah.
Like what does that look like so that I can capture that output and then pipe it or stream it
Yeah.
to the next transformation? Since it's like a glue language,
Yeah.
I would assume it's supported.
Oh yeah, of course. Of course. Yeah. So if you're in a Unix pipeline, which, Strike is designed to be in a Unix pipeline. The whole thing is Strike is like Perl or awk or sed. Like the whole point of Strike is to be stuck in a Unix pipeline. So the way there's millions of ways you can do this in Strike, but I have an inline documentation for Strike. So sdocs is the inline documentation. So it has everything in here. But if I do sdocs and then input, this shows you how you can slurp standard in. So you say input, so it'd be like this, input, then in your pipe. Does that make sense? So like cat etsy password, pipe in the Strike, and then Strike, do whatever you want to do with your input, your lines, and then you pipe in the less or whatever. There's a million things you could do. Like in Strike, you could do it's like strike-pe and then do your sed sub, like blah blah blah, blah blah blah. There's millions of ways you can do it. You can do LANI, like this is like Perl stuff where you're LANE, it says loop through every item and do whatever, like print if / whatever. Things like that. There's millions of ways of incorporating Strike in a Unix pipeline. You can also do STs. I have 3 different aliases: Strike, S, and ST. I just do S because I'm lazy. And Strike has a whole REPL. So you do S, start typing. I've got things in here like input, blah blah blah, everything's available in my REPL. Testing stuff out, blah blah blah.
Okay, but would I ever be like already in Strike, not pipe out of Strike yet, but call like a binary within Strike and then just have Strike pipe?
So if you're in like a program, like a script file, and you want to run external binary, is that what you're saying? You can
and then take the input from that and then.
So input and then what? What are you trying to do? Something like that. Take the input and store it.
Let's say I want to run a C file, get the output from that C file that does some algorithm.
You could do system myfile.c, or it's a binary, right? So you a.out or whatever. So some binary, and then you want to capture the standard out. You could also do backticks like in Unix world, like this.
Okay, and then that just assigns straight to the variable.
Yeah. It takes the standard out and assigns it. Yeah.
And does it do that as like a stream? So like.
No, that's eager. That's eager. to do it as a stream, you would have to do, what do I have for that? I have to look to see how you, I believe input, I forgot if input's eager. I think it is. Yes, it's eager. So it takes all your standard in and shoves it into a string, basically. I forgot what I have for, I know as a fact that I have a streaming standard in. Let me try to remember what it is. There it is, standard in. So standard in, so you could do cat etsy, you do find slash pipe in the strike, and then do standard in pipe in the whatever, or whatever you want to do. Then it'll be
Yeah,
streaming.
so like I might be able to like stream like tail dash F that is like
Yeah,
listening to a file change, and then it just continues
yeah,
to like just listen
yep,
to it.
yep,
Go,
yep, yep. You could do that. Standard in whatever, blah 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 blah, and yep, that would be a complete stream. Yep.
so like I could tail dash F a file,
Yeah.
type it to Strike,
Yep.
and then tail dash F the result that Strike's giving, and
Yep.
I could change that file through other means, and we would just see it updating.
Yep.
You know,
I believe so. Yeah. Yep. Yeah. Yeah. I have to. Yeah. I'd have to look at your exact use case, but yeah, you should be able to do all that. And yeah, I mean, I wanted it to be streaming because it's like, well, fine slash. I mean, that's going to take forever. I can't wait for that to finish. I got to stream. Hello. So yeah, Strike it's very useful. I use it, like I said, every day for a whole bunch of different operations. So it's got packages, namespaces. Any language, you got to have namespaces because otherwise you get conflict. So Strike doesn't allow you to overwrite standard library stuff. So all your own things you generally put in a package. So you say like, my package, whatever. Like, let me look for a package somewhere. Oh, like here, like SVC, that's the package name. And then you have a function, user defined function in that package. So that means fast is different than SVC fast because it's the package, right? They're two different functions. Does that make sense? You need namespaces. Have to have them. So yeah, Strike has tons of different inspection hashes. You can store like reflection basically because you have code that's written about your code. That's called reflection. Strike supports that. A lot of languages support that, like Java. You can loop through all your variables, whatever. Yeah. Now, Strike is designed to be in a one-liner environment. So, when you do SDoctor, well, what does that mean? SDoctor. Well, Strike, it has a bunch of different things. So if I do S-H, okay, Strike dash help, dash help, same thing. It goes through. Oh, so if you do S code, then you do S and then a string. Well, that if it looks like code, it's going to run it as like a one-liner. If it's a file, then it's going to run the file. So if you do S my file dot strike, I do .stk. That's my extension. I have various scripts. So I do S banner.stk. Boom, run the script. Okay. But if it looks like code, then it's going to run it as code, right? I don't need dash E. No. I can do dash E, but I don't want to. So if it looks like a code program, it's going to run the one liner. If it looks like a file, it's going to run the file. Right? That makes sense. So the other thing that Strike says is, so like SDoctor, okay. Well, that looks like code. There's no file extension, so it's going to run the function doctor. So that's what it does as doctor. That says, okay, what version of Strike? Where is it from? What's your architecture? What build is it released? Debug. Give me more information about the language, reflection, concurrency. How many threads do I have to work with? 18. I got the latest M5 Max, 18 threads. Where's your $home? Where's your Strike directory? Because in Strike, it caches all your scripts. Every time you run a script, it caches the bytecode. So the next time it runs, it's way faster. Where's the cache? It's in .strike/scripts.rkyv. What is rkyv? It's a binary key value storage. The key is the script name. The value is your script bytecode. I believe I'm the first person to do the bytecode cache in rkyv. I don't know. Package. Where do all your Strike packages get installed? Because I have Strike packages, right? I do strike install -G, then my package. Where does that go to? Well, SLS-G will show you. We'll show you all your globally installed packages, and they all go into the Strike store. And I can do strike up-G, upgrade all my packages. Things like that. Basic things from a package manager that you would expect. Update all my packages to the latest. Okay. How
And are
about,
these just
yep.
binaries that you're just getting the latest from them, or that you have to publish these yourself?
So,
Are they? Yeah.
yeah, what if I want to clean out old packages? Well, that's how I do it. Remove all my old packages. Update me to my latest. So what are these packages? Okay. Well, they're basically a combination of binary files and Strike code. So because it's written in Rust, right? The packages are also written in Rust. But so like my Strike GUI. What's in Strike GUI? Let's go in there. There is the package definition file, strike.toml. There's that, right? Every package has a definition. Then there's binaries. So say I want to install a binary Strike binary. It's not a binary. It's actually an executable. What if I want to, do that? Well, then I have that. Then the lib. What's in the lib? Well, there's a binary file, a dilib. What's that? It's Rust code compiled. That's what it is. It's native compiled library code. So whenever I'm in Strike and I say use GUI, what is that doing? Well, what it did, see, there was a pause there. Why? Because it took this binary file and stored it in memory. That's what just happened. And now I can do GUI, mouse move, mouse move, 0, 0. When I execute this, my mouse is going to go. Oh, well, if if Alacrity was written and they allowed me to do that, let me go in the terminal, which has better permissions. S, use GUI, mouse move, give me the tab completion because I'm lazy. Mouse move. Oh, here. Now give me the coordinates 0, 0. Oh, my mouse just moved. What the heck? Where's my mouse? Oh, it's over here now. Whoops. So, anyways, yeah. So, how are the packages written? They're written to have a binary file that you memory map. That's how they're written. And then on top of it, I have a Strike file that has all the wrapper stuff. So all the GUI, the functions, which basically are Strike code, which then executes the binary. And the binary has all the actual like mouse moving stuff, which in Rust they have a Nego. A Nego in Rust is the library for doing this. So basically Strike, what is Strike? It's basically a wrapper around Rust. Let's just be honest. It's basically Rust code in another syntax. That's really what Strike is. It's, I want to run Rust code, but I don't want to have to compile it and type all that stuff. So here's Strike. Here you go. Questions?
So if I'm using one of these like packages, like you don't have to manage the packages yourself.
You have
It's
to
just like
install them.
if Postgres comes out with a new version, I just up the version and
Correct.
it just auto grabs it. Or if
Yeah.
I want to revert it to an older version, I just revert it.
Yeah. So I do I have SPKG and then up-g, which is upgrade all my packages. But if you want to install at a certain version, you say si-g, and then you put the version like at 0.20. Whatever, or whatever. You
And
pin the version.
if I do that when I do s like update, it's not going to update that pinned version.
Yeah, I believe I have to check, but I believe it's based on I don't know if I have the pin stuff completely done, but basically there's this install.toml file and it has a list of all the installed packages. And I don't know. I have to look up and see if I have the whole pinning thing. But yeah, I mean, yes, you should be able to pin stuff at a certain version so that it doesn't get upgraded. Yeah. But the thing is, in your program, say you're writing a program, you're like, oh, well, I want to use a certain version. So that's what I have is in Strike when you're importing. So in Strike, you say use. So let me go to example, Strike GUI or whatever, or Strike. Strike, let's see. Strike. Strike MySQL, why not? So when you're like in here, so say you want to use you want to write a script that's gonna, query MySQL. So you import it, right? You have to import the package. Obviously that's standard, and you have to do that because you have to, in Strike, you got to mem map that binary. That's what this is doing. It's required. And then it's like, well, which MySQL, which version? Well, yeah, exactly. Which version? So in Strike packages, you have a Strike toml. And in the toml, you say, what are my dependencies? And then you put the version. So whenever you're in a package and you say use MySQL, it's going to use whatever package is pinned in your file, right? That's standard. But what if you're running this script somewhere globally and there's no package? Which version does it use? Well, if you don't put the version, it's just going to use the latest because there's no way to know. But in Strike, you can use I have completion on it. Use whatever. Well, there's a bug there, but you say use use MySQL and then the version string, and it uses that specific one. It's override. In this case, I only have 0.21.0, so that's the only version I had because I deleted all my old versions. So in Strike, in my JetBrains plugin, I have a Strike. I can look at all my Strike packages here as well. So I can go through and say, okay, here's the definition. So what that enables me to do is I can go on like my library code and I can jump to the definition file in the library file. That makes sense. This is jumping to a different definition here, but basically if you're writing code and you're like, well, where's the library code defined? Yeah, it's in these packages, Strike packages. And because I have these packages indexed by JetBrains, it just jumps to the index. So, yeah.
Okay,
So-
I have one last
Yeah.
question. Is there like a minimum hardware, or like, I know you said like installing it takes some time, but does it like take up any RAM? Like a minimum amount of RAM? Like,
No.
is there like a loading this language and an unloading
No.
this language?
No.
Or okay.
No, it doesn't take a lot of time. You just say brew tap brew install. It takes like 5 seconds. First of all, it takes whatever time it takes for you to download the binary and put it in the right directory. That's all it takes. And then as far as memory, well, is disk usage, it takes like 40 megabytes because Strike is a big binary because of all the stuff. 45 megabytes disk space you need for the binary. And then memory, the memory is whatever your program uses. If you create a list of like 1 billion items, yeah, it's going to use a lot of memory. That's happens in every language. If you do like
Yeah,
2 plus
so
2
only-
or whatever, it's not gonna
only
take.
when I'm using it does it take up memory. If I'm not
Yeah.
using the binary, it doesn't take up anything.
Yeah, the memory, all the memory usage is take this binary and memory map the binary. That's like a few, megabytes, like nothing. Then on
Then-
top of that, you have the memory usage of your program, which is all dependent on your program.
Yeah, so like here you have like a REPL that
Right.
you support as well.
Yeah. When I just do S, it's a REPL. Now I can just run any arbitrary strike code.
Super cool.
Yeah, and I have tab completion. That's based on the LSP. So I've got tab completion in the REPL. Actually, I'm using readline, which is a new shell. You heard of new shell? It's a shell, new shell. But I use readline because new shell is written in Rust. See, a lot of people are reading, things in Rust. I'm, by the way, writing Z shell in Rust. So it's a huge, massive project, which I don't have time to talk about here. But I'm creating the most powerful shell ever created, verified by a lot of people. So Z shell RS is the first compiled Unix shell. It runs shell scripts at native speed, which is like the first time that's ever happened. And it can compile shell scripts to native code. And by the way, Strike, all your Strike programs, you can compile to native code. You can compile all Strike programs to native code, and they run just as fast as C or Rust. There's no difference. And in fact, in Strike, you can actually take a whole project, a whole web app, a whole project, and compile it into one binary at native speed. It's called S-Build. It's awesome. S-Build. It's one of my S-Build. It ahead of time compiles your Strike script into a native executable. And then at that point, it's just as fast as any other native executable.
So that like strips out any bloat and basically makes
Yeah.
it like an
It's like
executable.
C. It's C. I mean, it's C. It's binary. There's no difference between it and C code at that point. Yeah, it strips everything. There's no interpreter. It's native.
Okay. What about like types or like memory allocation?
Types like strict static typing, like that stuff.
Yeah, like is
Like-
this like a language that doesn't care about that, or
Yeah,
does it
yeah.
support-
It's Strike is an interpreted language. It's dynamically typed like Ruby, Python, and stuff like. It doesn't care. Like you don't need to put the type. Why? There's no need for that. Like what it has is the signals. So if you do $X, well, that means that's like a scalar. It's one item, or it could be a reference. If you put the %, okay, it's a hash. If you put the @ it's a list. And then like if you want more types, like you can do that. Strike has optional typing, like in my OOP stuff. See, Strike is completely 100% OOP. It has class, inheritance, polymorphism, everything in OOP that is a full system. Completely full OOP system, classes, methods, and yeah, you have types if you want. You just say colon, then the type. It's like TypeScript, JavaScript, TypeScript. Like you want JavaScript with types? Okay, TypeScript, optional. So yeah, you can put in the type, in whatever if you want. But you don't have to because, well, the whole point of scripting languages is like, glue stuff. Like, do I really want to have to say, oh, it's an int, oh, it's a float or whatever? No, I don't care. So yeah, I mean, Strike has complete OOP. You can do all your OOP stuff, inheritance, if you want to do that. It has structs, has abstract classes, interfaces, final, packet, visibility, public, private, protected, static fields, constructors, destructors, life cycle hooks. It supports multi-inheritance. You can extend multiple classes, pull them all in. Traits, that's inheritance. So you impl trait, it's got your static bindings, operator overloading. If you want to do that, you can. Create a class of vec2, and then I want to be able to add 2 vec2s. Okay, well then you do operator overloading. So Strike, it uses $self to refer to your instance variables. That's how it does it. Like Ruby uses @signs, right? So Python uses self. Strike uses self. That's how it does it. I mean, you got to distinguish. Is this is it an instance variable or is it a regular variable? You gotta distinguish. So Strike uses self. You can, loop through all your fields in a class, your methods, your superclass, blah, blah, blah. Is this a dog, cat, animal, cat, blah, blah, blah. Clone, you can clone objects. You can add, all the stuff, convert it to a string, to a hash, blah, blah, blah. Whatever. Types. If you want types, okay, fine. If you want to type, fine, add the type. But I already know what the type is because what does it look like? Oh, it looks like an integer, so it's an integer. Looks like a string, it's a string. I don't need the type. It's pretty obvious.
So you're calling this a glue language, but you're using things like Postgres. Would you ever use this for an API, to
Yeah. So
a job for another language?
yeah, I have. Well, first of all, I have a bunch of stuff. I can do serve. Oh, it's a web server. Whatever. Okay. I have little things like that. But then on top of that, I have a whole framework called Strike Web. And so this is Strike serving up these files, whatever. But yeah, I have a whole framework called Strike Web. And Strike Web is if you're going to write a huge web app, you might as well use Rust, in my opinion. This is essentially a web app with over 1,000 different tiles. Okay, it's a web app that's shoved into a GUI format. And this is basically another web app. Well, it's kind of, everything's kind of web these days, to be honest.
Okay, so these are written in Strike with Strike Web. Before I thought you were saying you
No,
wrote them in
these are not written in Strike. These are written in Rust.
Okay.
Strike Web
Okay.
is a separate thing.
And so Strike Web is written in Rust?
No, Strike Web is written in Strike. Strike Web.
Okay. You were showing these other things that are written in Rust.
Yeah.
Why aren't they written in Strike Web, I guess?
So, why are Rails app written in Ruby? Why aren't they written in C? Ruby is written in C, isn't it? It's the C interpreter. So why do you write Rails app? Yeah, why do you write Rails app in Ruby? That doesn't make any sense. It should be in C. That's basically what you just said. it's like Strike Web. Why do you write a web app in Strike? Because that's the whole point. You write it in the language. If you're going to write a web app in Rust, then you just use Axum or whatever. So Strike Web, yeah, you write your web app in Strike.
Okay, so Strike Web is just like some sort of web framework that.
Yes, like Rails. So Strike Web is basically like Rails. It allows you to basically create a whole web app in like one command. It's like Rails. So like in Strike Web, you have route, and you have controllers. You say route and all this stuff. Like I can show it. I can't go over Strike Web.
It's MVC.
Yeah. It's just like Rails, but it's in Strike. It's not in Ruby, it's in Strike. And it's like super fast. Like really fast. Because Strike is one of the fastest languages ever created. So of course, you write a web framework in Strike, it's going to be really fast because it's right. It's
okay. So it kind of makes sense. Like your other ones that you were showing are just a little bit more custom. That's why you didn't use Strike Web for that. But if you were doing like your normal, but would fit within that framework, you would use Strike Web for that.
Like if it's the thing is that I'm not trying to compete with Rails or anything. Like if I'm going to do a huge web app, it's going to be in Rust. Like if I was just trying to do some like POC thing, yeah, Strike Web would work. But I'm not trying to compete with Rails because like that's not what Strike is about. Strike is about I have the whole thing that goes over Strike Web and all the different things, the generators that I have. You can generate apps, all these different, like you can generate an Amazon app with a theme, with auth, with admin like this, S-Web, new. Because like, why would I use Strike Web? Well, the whole point of Strike Web is I want to scaffold something. Like I want to build like Amazon in one line. I want to build Facebook in one line. Here we go. Right? That's what I'd use Strike Web for. Is like, I'm going to build Amazon and I'm going to build all these database tables and all these routes. Like I'm going to build 25 database tables and I want all this, I want to build a whole thing in one command. That's what I built Strike Web to be. And then after I got my POC, I'll rewrite it in Rust or whatever. But yeah, I don't have time to go over Strike Web, but it's just like Rails. It's got whole MVC structure, routes, configs, database migration files, test log, the Strike toml, like the bundle file and Rails. Like it's got everything Rails has, everything. I built it off of Rails. The whole point was like, okay, I'm gonna do Rails and Strike. Let's go. Everything Rails has, I have, and more. So Strike Web, yeah. But I'm like Strike. Why would I don't really do Rails? Like I do JavaScript. Like what the hell? And that's the reality. So like, am I using Strike Web right now? No, because I do JavaScript. Like I'm technically a JavaScript developer. So like everything's in JavaScript. So like Strike, where does Strike compare versus JavaScript? Well, JavaScript runs in the browser. Strike doesn't run in the browser. We're not apples to apples here. We're whole different things. Strike is really like command line, type thing, like Unix pipelines. Like it's not a browser thing, it's like Unix pipeline thing. And one thing I built in the Strike was terminal automation. So like I don't know if people had heard of expect, but it's like basically you SSH and it asks you for your password and you're like, no. I want it to put in the password automatically. People heard of expect and stuff. It's how you script command line stuff. Anybody heard of that?
This is new to me.
Yeah, like so say you want to write a script where you SSH on and then it asks you for your password. What happens in your script? It pauses, right? That's not good. Right. So there's a whole thing where you're scripting the terminal, right? So that's what expect is. It says, okay, spawn SSH. When it asks me for my password, send my password, right? when my prompt hits, send the command uptime.
Oh,
Get
that's
me,
sweet.
give me my output from uptime. Okay, close the
So
terminal.
you're actually regexing the pattern of the text.
Yeah,
that's
you're automating
creating
your
the prompt.
yeah, you're
and then
automating your
responding to
terminal.
it.
Yeah. That's called strike expect. I built the most powerful scripting thing ever. And that for terminals. And the thing is about this, it's really cool is I can actually do all of this like Ansible. You heard of Ansible? Anyone heard of Ansible?
Mm-mm.
Ansible is basically like I want to manage like a cluster of servers and do all this stuff like, you know, upgrade all their like login SSH on each one and do blah 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 blah. So that's what I modeled off of is like you can have like a whole list of servers and just like go and do all this stuff on them like completely autonomous. That makes sense. Like SSH on, do XYZ command, log off, blah blah blah. And Strike, why is it server farms first? Because I invented something. It's called distributed threading. So basically, you could create a cluster of servers, and then you use the distributed threading macro. So you say on my cluster of servers, on each one through a million, do all this code. Distributed threading macros. So, and there's a whole bunch of other things in Strike. So Strike is incredibly parallel. I haven't really gone over that, but if you look at Strike's parallel operations, they're basically I have the most parallel scripting language ever created. There's so many different parallel operations. There's parallel map, stream parallel map. There's chunked parallel. There's pgrep, parallel grep, parallel streaming grep, parallel for loops, parallel infinite loops, parallel while loops, psort, parallel caching loops, preduce with a init, pmap reduce, pany, pfirst, punique, pflatmap s, streaming, fan. So fan means like if I just do s fan, and say like P55 or whatever. So what that did, it says on all my 18 cores, run print 55. That's what it did.
Can I tell the language, like, don't use all my cores, use like
Yeah.
12?
Yeah, so the way you do this, you say S-J and the number of cores you want to use. That's standard syntax, like in make, say S-J, and then you say how many cores you want to do. So S-J. For every Strike program, if you want to limit the number of cores, you just do -J.
And what if I'm in like a Strike script? Do I just do it when I call the script?
Yeah, S-J for my script.
Or do I do it like inside the script itself?
You
Or
can do
like,
either way. Either way.
what
either
would
way.
it look like in a Strike script?
Strike script, you want to limit your concurrency. Actually, I don't know if you can do that in the script itself. Be like, oh, by the way, now I'm going to stop using this many cores. Actually, you can't do that. You can't do that because once you've entered the program, you're basically, whatever cores you have when you entered is like, that's the number of cores. You can't like say, oh, I'm going to start using 2 cores. Oh, I'm going to start using 10 cores now. It doesn't work like that. I don't even think any language can do that. You just immediately switch the number of cores you want to use. Like that doesn't work. Like what you could do is do chunked and stuff where you say, okay, I'm only going to do this number of chunks. Like that's something you can do. Like you can chunk your stuff. Like, oh, I'm only going to use like pmap chunk. Like I'm only going to process 5 at a time. Like, yeah, that's like pmap chunked. If that's what you're referring to.
I was just thinking like a shebang declaration, like at the top of the file.
Oh, yeah,
But-
yeah. So in the shebang, yeah, because in the shebang, you just say user bin env strike or whatever. User bin env strike, and then you say -J4 like that. Is that what you're talking about?
Yeah, possibly.
Yeah, that's how you do it in the shebang. But like in your script, you can't like switch the number of cores. That's basically impossible. Because the number of cores that like the threads you establish in your program, like that's set. You can't like shut down threads. Like say you enter a program and you're using 8 threads, like those 8 threads are allocated by the like operating system. You can't be like, oh, get rid of my threads now. Like it doesn't work like that. Your whole process has to die. Does that make sense? Like your operating system, when you run Strike, it says, okay, start the process with this number of threads. And you have that for the whole process. You can't switch like midway through the process. It's impossible. If that makes sense. You literally cannot do that. It's like that's like a basically like a fundamental operating system. Like every operating system, not every, like basically every modern operating system, you can't like switch. You can't be like, give me a new thread, by the way, or shut down these threads. Like whatever threads you have are what you have. Like if you want to use them or not, like that's you know, whatever your choice. Like you could start like in a Strike program, you can start a bunch of processes like independently, but you can't like throw up threads and shut them down. Like whatever thread you have or whatever you have, basically is what I'm saying. So to talk about concurrency, we got to talk about threading versus processes. Do people understand the difference? What's the difference between a thread and a process? Ryan, you know?
Probably not exactly. I know I've used processes in Elixir, and they're kind of like their own
Yeah.
app within a VM.
Yeah.
That's not
Yeah.
a thread.
So like, yeah, in your operating system, it has, so what does your operating system do? So like HTOP, these are all processes, right? So I got Z Shell, I got Chrome process, right? Ableton's got its own process, right? That's a process. Every time you run Ruby, it's a process. Every time you run Strike, it's a process, right? And within that process, you got threads. Okay. So like all of these processes, they got 18 threads because that's, you see on my CPU, I got 18 threads. See that? 0 through 17. So in Strike, by default, I can address 18 threads at once because of my CPU. But then processes, what about processes? How many Strike processes can I have? Basically, that's determined by the operating system, but basically I could have thousands of Strike processes. So I could have like 1,000 strikes running at once. Does that make sense? Whatever. So in Strike, I was like, okay, wait. So I could have 1,000 strikes running at once. That's pretty cool. I can only have 18 threads, but what if I had 1,000 strikes? And what if each strike had 18 threads? Oh, wait, that's 18,000 threads. Right? And so, yeah, Strike supports multiple processes. I have this whole thing called congregation. It's like a scriptable distributed compute. So basically I can create as many workers as I want. So I say Strike. So I say val workers equals congregation 4. So that means I've got 4 strikes to play with. On all my workers, I can be like, okay, go and do all this stuff on my workers. And then I can be like, okay, you're done. Kill the workers.
And so does it distribute this work across
Yeah.
the available threads?
No, these are processes, workers.
So the process is associated to a single thread?
No, they're 18. by default.
So like the processes can be distributed amongst the, I mean the threads can be distributed again amongst the processes.
Yeah, every process has 18 threads by default. Yeah. So if I have 4 workers, that's 4 times 18, 72 threads. But each one doesn't run, at the exact same time. You can only run 18 threads at once. So each one switches. That's the CPU that the operating system allocates the threads. So each worker can only be like, okay, I'm a worker, so can I use the CPU, please? And the operating system will be like, okay, you're first. This strike here, you get the CPU. Okay, you're done. This other strike gets the CPU. Okay, you're done. Now this one, right? That's scheduling, operating system scheduling. Right? So in Strike, you can Strike. This is basically inter-process communication. So you can say, okay, I'm going to create 18 or 4 strikes. And then on each strike, I want to do X, Y, Z. And then when you're done, give me the result. Okay. So this strike, you're going to go make a web call. This strike, you're going to go zip a bunch of files. This strike, you're going to go find me this one, this file, go search the file system. This strike, you're going to go whatever, sort all this stuff. And when all of you guys are done, come back to me and give a report. Yeah. And what's really cool about Strike is the first language that has AI primitives. So basically, AI is the name of the game. So in Strike, you can just say AI. You say Strike. It's literally this simple. So in Strike, you got to export your, API key, like export my Anthropic API key. And then you say Strike AI. Hello. What are you doing today, Mr. Claude? And then I need to print the result. So I'll say P. There we go. And now I got to do export my Anthropic key, API key, or whatever, in my environment, blah, blah, blah. Or whatever AI, you got to export the key. And then there you go. Talk to my agent.
Does that use the whatever installed CLI you have for?
Nope, doesn't use any
No.
CLIs. It calls directly to Anthropic.
Over HTTP?
Yeah,
Oh, nice.
yeah. So like in my script, I can be like, okay, so you create scripts that call AI. So you'd be like, okay, let's see. I need to know like the answer to my question. Answer to question equal to AI. What is the answer to 2 + 2, Mr. Claude? Okay. I got answer. It is dollar answer. Right?
It's so much more convenient having to do an HTTP wrapper. I haven't have to do something like that. It's like calling out to OpenAI.
Yeah.
And that's just all HTTP code. That is so cleaner.
Yeah, because I'm the first person that does AI everything. I have, oh my gosh, the freaking AI agents, because I have AI agents running all the time and like basically 24/7, and doing all this stuff. But basically they love, I don't know what it is, but the AI agents, they love to write AI related code. So they're constantly trying to call out to other agents. It's like, what? Because you're an agent, you're just obsessed about AI. It's like, they're trained to be obsessed about AI. So like, I'm like, oh, write the Strike script. I'm like, oh, I got to use AI. I'm like, no, just do it basic. Like, we don't need to use AI for everything. It's like 2 + 2 is 4. You don't need AI for that.
Yeah, I was telling someone the other day, I was trying to get it to do some artwork gallery thing where it would like
Yeah.
look at images, and it wanted to do an AI first solution. And I was like, no, make me a GUI where I can get a human involved, and it's like it always tries to push AI first as like the
Yeah.
solution.
Yeah.
And even over scripting, like sometimes you'll be like, no, just write a script. Like, don't try to solve this with AI so that
Yeah.
you can, like it tries to do it the most expensive, like
Yeah.
AI way.
Yeah. Yeah.
They
That's
burn
the other thing.
tokens.
Yeah. The tokens. It's all about the tokens, like Anthropic, everything's designed to burn tokens. So it's like, yeah, of course I want to chat you up because I want to burn your tokens. I'm like, shut up. Just give me the answer. I don't give a shit about your hello, bye, all your garbage, Mr. Nice Guy. Just tell me the freaking answer. So you got to go on your Claude MD and be like, stop being Mr. Nice Guy. You're just a bot. You're not a human. Shut up.
So now I'm gonna have like AI writing strike code.
Yeah,
But
that's what I do.
I'm gonna have an issue where it keeps trying to
Yeah,
use this AI keyword to like.
yeah.
keep
I'm
using
sorry.
AI.
I'm sorry that I wrote a programming language where the AI agents are addicted to calling each other from it. Like literally, I have this AI mock install thing, and it mocks out because like in all my strike scripts, like all my example strike scripts. So in my repo, I've got all these examples, like tons of them, and all my Rosetta code solutions. And then I have all the exorcism. So all the exorcism exercises I have in Strike answers. And I'm going to submit it to exorcism so that they put Strike on there. So like I have all the people familiar with exorcism, right? All the code solutions. Because Michael Dimmitt, he introduced it to me and I got into it, but you can oh shoot, I gotta log in. What the hell? I have a whole password manager thing that I wrote too, by the way. This is my Z Power Chrome. I talk about it later, but it's awesome. Password manager, download manager. It's like the bomb Chrome extension ever made. It's like everything in one. UA switcher, finded tabs, password manager, user scripts, post command downloads, extension filters. But anyways, exorcism, they have all these languages and all these code katas, right? So then I was like, oh wait, so Strike, I should freaking do them all. Like OCR numbers in Strike, how do I do that? Oh, okay, OCR here. Here's the Strike. Right there. Function exorcism, OCR numbers, convert, blah, blah, blah. Use the threading macro, blah, blah, blah. Go through the range, map, get the blocks, get the calls, do another threading macro, map, join, blah, 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 done.
So Jacob, when you do exorcism now, do you just use AI to do it, or do you
No,
like
because that's pointless. I never use AI to do exorcism. But that's pointless. I only use AI to be like, is there a better solution? Because why would I use AI to solve exorcism? That's literally a waste of time. That's like the stupidest thing you could do because you're just the whole point of exorcism is to learn language. If you use AI, you're just watching them. I mean, you can learn from them, but I only use AI to like basically teach me how to do it. But yeah,
But I mean, it could be a good test of your language if I like implement this myself, just using AI to give me confidence that the AI will pick solutions that work.
yeah.
Is it common, like, if you've done, if you finish one of these in, say, JavaScript, and you want to, like, okay, now we're learning Strike, go reference the previous solution you had, or do you prefer to do these, like, pick a problem you've never done before?
Yeah, no, I like to compare. Like that's the whole thing about Strike is I was influenced by exorcism because I'm like, oh, so in JavaScript I got to do X blah 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 just to do blah. Like that's stupid. I want a language where see like my language. Why do I need to to put like, this is a microblog. So you take the Unicode characters, you get the first five or however many. And then you take five, at most five, and then you join them, right? So like most languages, you have to say function $arg is equal to $arg, like, all the stuff like, okay, take 5 from $arg, and then I'm going to join, like, right? Like this is that, like that, and then I'm gonna oh, I gotta get the graphemes, so I gotta split on that, or get the graphemes from that, and then like that. Oh, there it is. Right? See, in Strike, you can do that. You can be normal. But who wants to be normal? I would rather do this. Look, I do the thread operator. I take the first argument, implicit, pipe in the graphemes, pipe in the take 5 join. I'm done.
Yeah, so like since you have so many keywords, you're potentially pretty code golfy. Or
oh
you're,
my
or
God,
you're
I'm incredibly golfy. I'm a golfy. Strike is literally one of the most golfiest languages. You should see some of this golfing. Strike, by the way, like, look at this one. Strike is the most concise ASCII only language ever created. I could show you basically proof of that. But like golfing and Strike is insane, yes. Strike is basically my golfing language. I created Strike to golf because I was like, a function, I don't need braces, I just say equals. An argument, I don't need an argument, I just say underscore. It's so obvious. Underscore is so much better than naming an argument. It's so simple. So like this, yeah, it's freaking golfing as hell. This is ETL. So you you take like a dictionary and you convert it from one format to the other in ETL. So like the key is 1 and the values is a list, and you convert it into a different format. And so like this, I wrote this, which is like incredibly golfy. Can anyone tell me what this is doing?
Okay, so it's it's doing a lowercase of the value that's passed in. It's doing like a
No, it starts here. It starts here. Keys right here. This is where it starts.
So the keys
Of the dictionary, which you pass in as the first arg. That's the first thing. Get the keys. That's what this is.
The keys.
Then you map over the keys, right?
And I do the thing on the right, which is the
yeah, you map over the keys, and then here you map over the values. That's what this is doing. You map over the values, and then right here, so you take the lowercase of the value. It's implicit right there, and then the other thing is this.
You do like a string comparison.
No, it's just loops. There's no string comparison.
What does the less than sign mean in this?
Okay, yeah. So this syntax, this and Strike, I invented this right here. So basically in Strike, what that is underscore. So in Strike, there's this thing called the topics. So underscore is a topic. I have a whole diagram. So underscore is a topic. This is also the topic. This is also a topic variant. Because in Strike, this means go up one level of nesting and give me the previous topic. I have to demonstrate this. Yeah, I invented this. Because I was so annoyed because I'm like, well, I want to refer to the topic above me. So this is going to get a little crazy here. So basically in Strike, you have all these different topic chains. So every time you go down into another level of like braces, you increase the depth okay, of the stack frame. And
So,
then you're able to reach up and strike. The first language, you reach up the topic and you pull off whichever implicit parameter you had.
oh,
And you can go up 5 levels in the stack frame. And you can refer, so that's the 5 levels up right there. So you can go up 1 level, up 2 levels, up 3, up 4, up 5. Or you can do up like this syntax, up 3 levels right there. And then when you go up the levels of the stack frames, you can also, well, it's not really stack frames. It's just like braces, like the interpreter stack of braces depth. And then you can refer to not just the first argument, but any argument. So you can refer to the second argument 5 levels up, or the 99th argument 5 levels up, whatever.
this feels like
It's nuts. Like, look at this. So you map, so you have a map, right? And you have multiple levels of map. So you map a list of 10 to 20. Okay, so you're going to take 10 to 20, you're going to map over it. Then inside here, you're going to do another map. Okay, inside your map, you do another map over your inner. And then, so how do I refer to the outer implicit closure parameter? Right there. So I refer to the inner map value there and the outer one like that.
this feels like a list comprehension in Python,
Yeah,
but
yeah, it's freaking insane. And it's cool though, because I can so like I can do all this crazy shit like this. See, like, okay, I'm a map inside a map inside a map. So like 5 levels of mapping. And then I want to refer to the second argument 5 levels up of this map or whatever. Like, how do I do that? In other languages, you have to store the value, right? Or use named, like Strike, it allows you to do named parameters like in Ruby. So like Ruby, people are familiar with Ruby. You can do like map, and then you do A, B, blah, 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 like that, right? Like print A plus B or whatever. So like Strike, you can do that as well. I support that. So you say like at list, pipe in the map, blah, 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 right? Yeah, and then like collect or whatever. Okay, you can do that in Strike, yes, if you want, but you can also do, underscore plus underscore 1, right? Like you can do that in Strike. You can do that in Ruby too. You can do that in a lot of languages. But what Strike has that nobody else has is I can say, okay, I'm going to go this, and then I'm going to go in the map, and then I want to refer to the topic, but actually I want to refer to the topic above me. And then I want to refer to this topic. So like that chaining is what Strike can do that nobody else can do. And then I can be like, okay, I'm going to map on this one. I'm going to go 2 levels up, and I'll refer to the second implicit parameter. Hype that. It's like, okay, right. Now we're turning into some mathematical formula. And then you like
so hard to follow. Like, how do you know like how many parameters you're sending in, or like or what order?
Yeah, that's why I limit it to 5. So it's like that 6th level just kills you. But yeah, you can do like, oh, give me the 99th parameter 5 levels up. Or that would be the 100th parameter up 5 levels. That's valid in Strike. Or you can say the 1000th parameter, implicit closure parameter number 1000, 5 levels up. That's valid Strike. But yeah, I mean, I just did that because I could, and why not? And Strike is very fast. It caches all your scripts. There's a file. So every time you write a Strike script and you run it, it gets cached. So it stores it into Strike, into the scripts.rkyv. So every script that I run gets cached as bytecode. And then I can view the cache like here, like, oh, actually I only have 2 scripts that are stored. But like every time I write the run, I have all these strike test examples, examples, run all these. See, it runs all these strike scripts. Oh, I had a failure. But yeah, I have a whole unit testing framework built in the Strike. I use it all the time. But whenever I run scripts, now you'll see the cache view is much bigger because all my tests got cached. So it's bytecode. So that means that the next time I run the test, it's going to be way faster because I'm not lexing, I'm not parsing, I'm not compiling. All I am is taking the bytecode out of my binary database and I'm shoving it into my VM. And if my VM can, it'll compile to my JIT cache. And if so, basically I can be basically like running Strike scripts at near native speeds for like no effort because I have this Fuse VM JIT cache. So basically it's like the first time I run a Strike script, it's pretty fast. The next time I run a Strike script, it's like native fast. Now we're talking nanoseconds, basically. So yeah, but anyways, I'm at time, so I only got through a very small percentage of Strike, unfortunately. But
This was exciting. This was awesome.
but like Strike is like the language that I have a whole book. I'm gonna do like a book on it. It's like 4,000 pages already. I don't know.
I'm really impressed with like how much you included here, like test framework, the LSP, the syntax, the database connectors.
Yeah, this is
I would have more database stuff if there was time.
Yeah, like where's my freaking PDF? Here. Strike language reference. Oh, it's 1,200 pages, my bad. But yeah, so I go over, like I'm gonna publish this book and it goes over everything you can do in Strike, which is like, oh my gosh, insane. But
what is slurping? I think you.
Yeah, slurp is basically like cat. You just take the whole file, you get all the bytes and store it in memory. I have cat as well, so Strike, so I can do oh, the one last thing I'll show you to impress you is this. So I go, there's a lot of things that Strike can do, but this is really cool. So you do this. So I'm in Strike. I'm in the Strike repo. Okay. It's got like 2.4 million lines of code. So I'll do this. I'd be like, okay, I want to, in parallel, I want to cat all my Rust files. Okay. So Strike supports all Z shell globbing parameters, by the way, because I'm rewriting Z shell in Rust. So I can do everything. Like I can do, oh, give me all my, that wouldn't work, but like whatever, executable, all the Z shell stuff. I say, give me all my Rust files recursively, cat them all. So Strike says slurp or cat or whatever. So I do C, and then I say, I want to get, okay, I only want to get the letters. So get rid of everything else. No punctuation. Now I say I want to get the frequency, and then I want to put in a histogram, and then I want to print it out. And then I run it. Okay. Let me just do, I've had some issues with some of the Z shell globbing stuff. I think that Z shell globbing is broken currently. Is *start@rs should work. Oh yeah. Anyways, I'll just do cargo.toml. So I cat cargo.toml, get all the letters, give me the frequency, then do a histogram. I can also, and I could convert it into a PDF too, like this, to PDF, and then open the PDF.
Could you do ** without the .rs and just glob
**?
everything?
Yeah, you could, but then you're going to get directories. **. You can, but you're going to get directory, so you'd have to do that. Only give me files. That would work. But the
Try
thing
it.
is, no. Okay, I'll try it. This is going to take a while. We're talking about 2.4 million lines of code.
Do it.
It's running right now. It's taking a while. Let's see what it's doing up here. Oh, it's right there. Running. I don't know how long it's going to take. I don't know what's going to happen because I'm not sure. The Z shell globbing thing is Z shell is under active development. Z shell RS. I mean,
You could kill it too. So, but I mean, this is interesting because you're also sharing your screen and you're on a video call. So I guess it doesn't interrupt, those processes.
yeah,
Good.
yeah. But basically, anyways, I'm rewriting Z shell and Rust, and then I'm using Z shell and Rust as a library instead of Strike. So basically, I can do bar charts and stuff like that too.
Wait, with your dot thing, it looked like it was working, right? So if you use the same syntax with the RS on there, shouldn't that work?
Yeah, but I have to go check and see what's going on with the Z shell glob thing, because I'm importing it from Z shell, and every time I update Z shell RS, it's causing issues. I have to go check. And also I've had some other bugs that I've been fixing, and I have some regression. I just saw one of my tests was failing. But anyways, yeah, so like you can cat all the files or whatever, get the letters, create like bar charts and histograms, all this shit, and do it in parallel too. So that's what that does. It does all this stuff in parallel. So anyways, yeah, so like right now, the roadmap, what I'm doing is, I'll show you this before I'm done. So like right now, my roadmap is that I'm not really working on the main Strike repo, except for just I use it like dog fooding. I'm using it all the time, and I'm discovering like little edge cases. And I like right now what I'm doing is I'm mostly expanding out my packages system. So like I put a lot of effort into doing like, all my office stuff. So like open all my Excel sheets and blah, 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 and blah, 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 all of that. So there's been expansion of my package system. Then, so like I'm doing that. I expanded out my Z shell completions. I've got like 40,000 Z shell completions now, which is like insane. Nobody else has close to me. So I've been doing that. Like, and then the big thing, I've been working on my GUI apps like Trader View and my synth app, which like this is like the most powerful synth ever created, to be honest with you. I got this whole patching system where you can draw it's all DSP stuff. I've got that I've been working on, and then I got like able to, because I'm a music producer, so I've got like plugins. I'm making the plugins and stuff. Then I made the audio app, audio and things like PDF app indexing. But then I'm selling software, by the way, now. So I have an app store, and my app store here. So I'm selling software. I have my own company, and I'm selling synthesizers and synths, MIDI effects, and my desktop app. We got a whole like tax system and scanner trading software. I'm building like really insane trading software because I do that, customized dashboards, all this stuff. But then, so like my open source stuff, I have Strike. Yes. I have awk. I rewrote awk in Rust. I have LSOF in Rust. Nmap, IFTop, RS. I wrote that. This one, I wrote both of these. This one, it tracks all your network connections right here. And this one shows you all your disks. And then I was tempted to do rewrite tmux in Rust, but I was like, I don't see the point. And so then I was like, okay, I'm going to write the status bar in Rust. Hey. So I wrote the power line RS. I did that. So I have my own tmux status bar. And then,
You
sorry.
stop sharing, by the way.
Yeah, my freaking screensaver. So then, I did the power line thing, power line RS, which is like a big deal because a lot of people like their tmux power lines. And I've been adding segments. So I've got all these custom segments that nobody else has. I've got like a CPU or GPU temperatures, Fuse VM cache. I have segments for Strike caches and all this stuff. I've got weather and CPU, GPU temps and all this stuff. I put nerd fonts in there and stuff. So I did that, the Powerline RS thing. That's called Powerline RS. It's on crates. It's pretty cool. It's like super fast and expandable. And then I have all these Z Shell plugins, which I've been not really working on a lot, but then there's the virtual machine, Fuse VM. But the big killer one is the Z Shell RS, which is taking me forever. I'm rewriting Z Shell in Rust. I'm like the first person apparently, but it's at like 700,000 lines of code of Rust. And it's taken me forever to port all of Z Shell because I'm tired of Z Shell. It's slow as hell. And Bash is, like all these shells are so slow. So I'm like, forget it. I'm writing my own shell. It's going to be the most powerful shell ever created. It's going to run at native speed. I'm going to take shell scripts and I'm going to freaking compile them to native code. I'm done with all this. So then I'm creating Z Shell RS. See, I've got like hundreds of Z Shell scripts. It's just Z Shell syntax, but I run them way faster. I'm literally like 10 times faster than Z Shell. And I have my own unit testing syntax. I'm like the first shell with unit testing in the Unix world, I guess. And then I've got the Z Shell plugin for JetBrains. So like I can debug Z Shell scripts. So I debug it and I step through my Z Shell scripts. See, step through debugging Z Shell scripts. That took a while. I can also debug Strike scripts, by the way. So I can step through them, step in, step out, blah, blah, blah. But yeah, the Z Shell, rewriting Z Shell and Rust is taking forever. I mean, it's going to take me like a year at least because it's so many damn edge cases. My parity suite is like over 50,000 tests already. Just like thousands of, because I'm writing Z Shell in Rust, but I don't want to have to change any configs. So then
Do you like start with their test suite and then
I already went through Z test.
yeah.
So I have the Z. Well, first of all, I used to contribute to Z Shell, but then I was like, oh, their code is shit, which it is. Z Shell is shit code. The C code is shit, and so is Bash, by the way. Their C code is trash. So I was like, okay, their shells are trash. Bash is trash. Z Shell is trash. Fish is okay, but it's not powerful enough for me. So I'm like, okay, I got to create my own shell, I guess. So then I've been doing this and I have like thousands of parity tests. You see all these parity tests I have. So like I have to be able to, where's the monsters? Here's the monsters. Like trying to parse out these freaking these things, these parameter, not those aren't that complicated. I don't know, some of these monster mega parity things. But like this parameter, so like if you're familiar with Z Shell, damn it, they have all these crazy parameters, expansion things like this where they nest them. And that's been taking so long to try to parse that out. But yeah, it's Z shell has taken me a long time to rewrite. It's definitely the most challenging thing I've done is to try to rewrite Z shell and Rust. It is so hard. But I have like 50,000 parity tests passing. So I have, 50,000 tests. I run them. I compare Z shell versus Z shell RS. Is the output identical byte by byte? If it is, it passes. If it's not, it fails. And so I have like 50,000 of those, but I keep on discovering edge cases. And every time I freaking, I'm trying to run Z shell RS, as they say, Z shell RS, and then it goes through and it says, oh, okay, Z and Ed is blowing up. Oh my gosh, like all this stuff, trying to run all my configs with Z shell RS. And it's like taking forever. Like, oh, Z and Ed temp stub. Oh my God. Like, oh, that's failing. So eventually, though, I will have my own shell, and it's the first shell with the daemon as well. So I start the Z shell RS daemon, and it serves all my client shells.
ETHUSD new high of day.
Oh, that's my stock trading app. Sorry. I have algo trading. That's another thing I'm working on is I have bots trading stocks for me, which is going okay, but I have alpaca and all this stuff. But yeah, my app, it announces
AAVEUSD new high of day.
some crypto just hit a high of day. Sorry. But anyways, yeah, so I forgot that was even running, but it's like announcing my high of days because I have a crypto algo trading, and it's going through and filtering. It does the SIP stream. It filters out all the crypto and stocks that are squeezing. Anyways, but Z shell RS, that's really killing me. But eventually, I will have the most powerful shell ever created with the daemon, and every shell client registers with the daemon. So basically, you could have like 100 shells, and they all start instantly because all they do is grab stuff from the daemon, and the daemon just stores stuff in the binary databases. So like the whole thing with Z shell is, oh my God, it starts so slow. Yeah, it does start slow. That's because it has no freaking cache. So now I have a shell where it's like my shell starts in 10 milliseconds no matter what. Because I don't run config. All I do is grab it from the daemon, and the daemon has everything. And it's also like, oh, well, I have 100 shells, but they can all communicate because guess what? I have the daemon. The daemon can just sync everything between all my shells. I don't need tmux. I have the daemon. See? So I have a shell coordinator in Z shell RS. And I have all these other things. I'm the first person to have AOP in a shell where I can intercept everything to the line level. But I gotta have to talk about that later because I'm out of time. Maybe next talk about Z shell RS and how it's all the inventions that I have in it and how it's the most powerful shell because of all these different things. But
yeah, I'd love to hear about that next time.
Yeah, it's the thing is all this stuff is like millions of lines of code, and it take months to talk about it. But I have like 3 books. I have a book on Strike, a book on Z shell RS, and a book on what's the other book? I don't know. There's some other book I forgot, but I have 3 books written, so I'm just trying to go through and get everything polished before I publish them.
Thanks, Jacob. This was great.
Yeah. No
Thanks,
problem.
Jacob.
Yep. Thank you, sir.
Let's stop the recording here.
Sounds good. Yeah, it's crazy.